Hello everyone, this is Anastasios, or Tash for short, Nikolakopoulos, and along with my colleague Konstantinos, or Kostas for short, Hasapas, we will do the demonstration of our Net Company Intrasoft's component on task 4.4, Automation and Scalability of Identity, Intelligence and Investigation. So, what are the main challenges that our component seeks to resolve, seeks to address? First is to fuse the outcomes of multiple physiological and behavioral biometrics towards estimating the identity of the person involved in a crime scene. Therefore, the component should provide recommendations through a multimodal system, delivering informed recommendations tailored to the reliability of each biometric modality under consideration. Therefore, each practitioner could make risk-based, privacy-enhanced, and security-centric decisions with confidence and precision. Second, the component should address or should facilitate the investigation process through enhancing the context awareness of the crime scene. That is why the component should combine biometric data along with their derivatives so to create a storyline of the crime itself. And this storyline should include people involved in the crime, potential key evidence that stand out from normal context, and everything that could be proved as useful in order to provide a very vital narrative to the law enforcement agencies and police agencies. Last but not least, the component should be adaptable to different implementations and versions, tailored to several application domains or to the applications themselves. So, the technology that Task 4.4 finally leads to implementation is a component named Investigation, Recommendation, and Enhancement. What it aims to do is to fuse biometric matching scores and provide recommendations for potential suspects, potential criminals, as well as assisting the investigation with incident narration generation. It consists of two subcomponents. The first subcomponent is named Intelligence Refinement and Recommendation System, IRRS for short. IRRS utilizes biometric data available from a criminal investigation and retrieved from the appropriate data providers in order to provide insights and recommendations to the end users. The second subcomponent of Investigation, Recommendation, and Enhancement module, or IRE for short, is named Investigation Enhancement System, or IES for short. It aims at providing law enforcement agencies and forensic investigators with additional information regarding the crime scene and its actors, such as a complete narration of the investigation process. And this is the architecture of the IRE, consisting of both IRRS and IES, along with a data acquisition agent to retrieve data and information. The functionalities of the first subcomponent, the IRRS, Intelligence, Refinement, and Recommendation, is first the retrieval of matching scores and crime-related features, then the storage of biometric data and derivatives of them per each investigation, then the assignment of trustability scores, and with the term trustability we mean biometric reliability scores, and last but not least, the suspect identification and along with the confidence level estimates. As regards the investigation enhancement system, the first step is the retrieval of all crime-related information through the data acquisition agent, then the process of data cleansing, that is, data pre-processing and processing, such as checking for potential false data samples and applying basic text and string type processing techniques. The data preparation session, where each piece of information is categorized based on context and prepared for the next part, which is the narration generation by the use of generative AI model to produce a narration of the investigation process. Last but not least, all the generated data are sent to the front end, to the UI. This is the input and output data that are used within the IRE. This is a brief example, and as input data will be the biometric matching scores, the suspect IDs, suspect unique identifiers, soft biometrics like the age and gender information, and additional features like the clothing color or potential face mask, glasses, etc. As output data, we will have the list of suspects along with the corresponding confidence levels and a narration of the investigation process exploiting the information from the soft biometrics and additional features we saw before. During the first reporting period, and that is the implementation status, Netcompany Intrasoft focused on the development of the first subcomponent of the IRE, the IRRS. This plays a significant role in use case 1. So the following implementation and demo will be about the IRRS. IES, the second subcomponent, is under current implementation. So in relation to the use case 1, the objective is to identify criminals based on the fusion of multiple biometric modalities collected from the crime scene. So the two steps that IRRS achieves, two fusion steps, is first the recommendation of suspects based on the fusion of two biometric modalities, face and voice. And the second step is the fusion and therefore the recommendation of based on three biometric modalities, face, voice, and gait. Now let us proceed to the demo to see it in first hand.
The first part of the IRRS component is the data acquisition system, where we fetch the biometric scores from REST APIs provided by the biometric partners. Then we use this data to save them in a local SQL database, and we make some calculations to find the final suspect. Meanwhile, we check when we receive the data for duplicate records or for new features or modalities added in the endpoints, so as to add in the table new columns for new features. Now we will run the application for simplicity and for the demo purposes. We have created the JSON server, a mock server with 100 random IDs and values as suspects, and we will run the application to fetch the data and save them to our local SQL database. This process is scheduled to run every 15 minutes. So our component checks every 15 minutes if there are updates on the endpoints. And now we will refresh the database schema, and we will open the biometric data table. Here we have the user ID, the face score, the gender from the face modality, the age, the Boolean attribute mask, the same with glass, if the suspect wear glasses or not, top clothing color, bottom clothing color, the suspect ID, the voice score, the gender from the voice modality, the gauge score, and the behavioral score. All of them derived from the biometric partners analysis. So the next step is the calculations. We fetch the data from the database, and we make we use some algorithms and calculations to narrow down the list of the suspects. Here we have a list of 100 suspects. We narrow down the list to the 10% with the highest score, and by score we mean a composite score using the scores of each biometric modality, depending of course on the use case scenario and the taxonomy. We'll talk about this later. Then we use the gender from the face modality and the gender from the voice modality. We fuse them to now narrow down further the list, and we end up in one suspect with the highest score, taking into account all the metrics I said earlier. About the scenarios, we have defined 4 different scenarios, and we will add more based on the use cases. For the first use case scenario 0, for example, we use face score, voice score, gauge score, and behavioral score. We use a taxonomy based on the research INTRA team have done, but this will change dynamically in the future. And we can test the result with a postman.
We serve our output via REST API. So here we can test, for example, the scenario 1, which takes into account face score with 0.6 and voice score with 0.4. And if we send the request, we take the top suspect ID, which is the 83, with top suspect score 0.956, and all the biometric scores provided by the biometric partners, and the soft biometrics. We can test also another scenario, for example the scenario 0, which takes into account face score, voice score, gauge score, and behavioral score with different percentages. If we send the request, we take the top suspect ID, the result with which is the ID 40, with top suspect score 0.9155, again the biometric scores and the soft biometrics. And we can also test another scenario, for example the scenario 2, with gauge score and behavioral score. And if we send the request, we take the result, which is the ID 84, with top suspect score 0.96, and again we have here the age and all the rest of biometrics and the biometric scores.
Thank you for your attention.